So we are starting. Okay. Allora, good morning, everyone, and welcome in this session. Today we have 5 presentations, and each speaker we have 50 minutes to present the work and 5 minutes for the question. So we can start with the first presentation, that is integration of geomatic, geophysical and chemical data in a GIS environment for monitoring contaminated soils. The speaker is Enrica Vecchi. Enrica, can you start?
Good morning, everyone.
Share your monitor. Okay.
You see?
Yeah. No?
No? Okay.
No, yes. No?
Okay.
No, Enrica.
No?
No?
Yes,
we see the screen.
Yes. But not the presentation.
Okay, yes. Okay.
Okay.
Okay. Good morning, everyone. I'm Enrica Vecchi from University of Cagliari, and today I'm presenting you our work about the integration of geomatic, geophysical, and chemical data in a GIS environment for monitoring contaminated soils. The objective of the study is the integration of a multidisciplinary dataset concerning a phytostabilization process on a contaminated site. And all the data have been collected within a concluded research project named KARMA. Today I'm presenting you the first result, which are the 3 different datasets that we acquired, analyzed, and imported in a GIS environment. The context is a contaminated area where we applied a phytoremediation process, and then we performed 3 different kinds of surveys, which are geomatics, geophysical, and chemical. Today I will go deeply into details for the geomatic part, while I will only present you some result of the others. When dealing with a multidisciplinary process, for sure a proper data integration and a challenging interpretation process are required. Our context is Sardinia in Italy, where more than 1,000 of contaminated areas have been stated in 2018, among which about 200 are related to mineral sites, and something less than 200 are located in southwestern Sardinia, which was indeed a mining area since the mid-18th century. For this reason, in 2003, the region promoted a plan for the reclamation of these sites. Our study area, in particular, is located in the south of Sardinia, this area has suffered for heavy metals contamination due to the coal spilling in some close extractive areas. We applied 2 different approaches in the area, which is this one, you can see in the right figure. Most of the area was treated with organic soil conditioners and named the substrate area, while only a small sector that you can see in black in the figure was maintained without any treatment and named the witness area. We applied, as mentioned, this phytoremediation process by planting about 600 young plants. And we will see in the next slide something more about this kind of process. And we used 3 different plant species, which are poplar, lentisk, and oleander. If you are curious about our project Karma, you can find the attached link here. Some more details shortly about the phytoremediation process. This is a treatment for contaminated soil that involves different mechanisms, which depends on the specific pollutants. Different kind of plants can be used and combined together using different reclaim methods. And in particular, this kind of process exploit green plants to limit contaminants in soil and water. Thus, the pollutants are not completely removed, but only constrained or stabilized in a layer located between the roots and the subsoil. This leads to 2 important conclusions that are that pollutants are prevented from flowing downward toward the water table and upward along the plants. And for this reason, also the plants are classified as cannot be classified as dangerous wastes. Therefore, this kind of treatment is both convenient from environmental and economic perspective. About the field surveys, as mentioned, we performed 3 kinds of field surveys: geomatic, geophysical, and chemicals, and also some direct measurement on the field about the height of these small plants. We identified 4 different epochs where the T0 refers to the before planting situation, so it's used as a reference, and the T3 is related to 10 months after the planting. Going deeply into the geomatic techniques, we used 3 different techniques, which are GIS, GNSS, and UAV. The first are platforms fundamental for this kind of multidisciplinary studies, since they allow merging different data sources, and they provide a wide range of spatial analysis and tools, and of course an effective data visualization. GNSS are used in the study commonly as supporting techniques, since they provide the proper management of the reference systems, and also they are used to acquire specific point positions, such as in our case the plant's position, or the ground control points positions, which are used to georeference the UAV products. UAV platforms are able to carry different kind of sensors and can provide different kind of data. In our case, we use 2 kind of sensor that we will see in the next slide to provide both an accurate metric description of the area and some description in terms of qualitative parameters. Here you can find the specific characteristics of the 4 UAV flights that we performed at different epochs. So we acquired both RGB images and multispectral images, providing different kind of outputs and indicators. In any case, we ensured the overlapping between the acquired images by auto-planning the flights, and we acquired 8 ground control points in order to provide the proper georeferencing in the official spatial reference system in Sardinia. For what concerns the RGB images, this is the workflow applied for the processing. So we started from applying a standard structure from motion approach in the Metashape software, providing the UAV point cloud. Then we applied a vegetation filtering in Cloud Compare, which provided the digital terrain model. This is the same workflow for each epoch, reasonably. And so for each epoch, we had both the digital terrain model and the digital surface model obtained directly from the UAV point cloud by rasterizing. Then, simply by differentiating these kind of models, we obtained the canopy height models, which represent the height of the plants in the whole area. And finally, applying a GIS-based operation, which is the local maxima approach, we obtained in each plant's position the specific height. As for the multispectral acquisitions, we obtained qualitative parameters, and also in this case, we applied the structure from motion algorithm from Metashape software, and using the raster calculator tool, we were able to obtain 3 different maps representing 3 different parameters, which are the NDVI, the GNDVI, and the CCCI. They all refer to the vegetational status in some slightly different ways. So the first can be used to express the vigor of the vegetation. The second provide information about the presence of water, the humidity, and the nitrogen content. And the last refers to the amount of chlorophyll in the vegetation. Here you can see some of the geomatics products that we obtained. The result of our reporter 42 as an example. So for each epoch, we obtained the orthophoto, the digital surface model, the canopy height model, and the resampling of the plant's height in the plant's positions. In general, what we can say is that the very low height values that we dealt with since the plants were very, very young and the sparse canopies made the processing of this part very challenging. For what concerns the products of the multispectral acquisition, here you can see some example for the T3. In general, we can say that there is a slight difference between the area treated with substrate and the area and the witness area. Whereas in general we deal with very, very low values since there is a low presence of biomass and our plants were still very young. Going into the geophysical technique shortly, 3 different steps were required: a preliminary analysis of the site's conditions, in order to analyze possible issues during the surveys, the geophysical data acquisition, and repeating the surveys, we could obtain the monitoring of the resistivity values. Here you can see some results of the geophysical acquisition. On the left, the continuous map of the resistivity in the area. That gives us information about heterogeneities and the direction of these values or the presence of some anomalies. On the right, you can see a result of the inversion of the EMI measurement. This kind of process provides information about the spatial distribution of the resistivity along the different depth of the soil. So we can difference by frequency and then obtain this kind of graphs. Lastly, the chemical analysis. The main goals of this part is to evaluate the pollutant interaction dynamics in the soil-plant system, and 4 different steps are required. The first is the soil characterization before planting, so at T0 in terms of metal content. Then there is the actual planting of the area following defined configurations. The third step is the sacrifice, so the extraction of some sample plants belonging to different species, and then we have the chemical analysis. The phytostabilization treatment can be assessed also comparing the values related to the pre-treatment and the post-treatment conditions. The result of the chemical analysis are given in terms of three biological indicators, which provide a description of the concentration along the plant system. So we difference by concentration in the PGM part, in the soil and in the roots. And then we try to analyze where the most of the concentration is still remaining. We give this kind of indicators for 4 different analytes that are zinc, lead, cadmium, and arsenic. Here you can see some of the results of the chemical characterization of the sacrificed samples, 42, and overall we can say that the metal accumulation was bound into the root system, so not affecting the plant's vigor. We can make other considerations, or better, we can make other consideration about the different behavior of the different plant species in terms of biological indicators. Lastly, going into the GIS data integration, we imported all the analyzed dataset into the same QGIS project in order to see together and to query some information and to merge different data sources. Here you can see one of the geomatics product, that is the orthophoto related to the pre-planting situation. Here you can see the NDVI map together with the CHM heights extracted in the GNSS plants positions. Here you can see the result of the GNSS survey in terms of plants position merged with information about the plant species and the directly acquired plant site. About the geophysical acquisition, we were able to resample the very dense dataset in the GNSS plant positions. And finally, for what concerned the chemical investigations, we were able to visualize the position of the sacrificed plants together with their associated biological indicators. In conclusion, we dealt with a phytostabilization treatment in a contaminated area. We applied 3 different disciplines, which are geomatics, geophysics, and chemistry. For each specific discipline, we performed their field surveys, their data processing, and we analyzed the specific results. Finally, we provided a GIS integration able to visualize the different data sources at different spatial scales and to combine spatial and non-spatial informations together. What we are working about now is to produce a public data set about this multidisciplinary research, which can be used both for research or for to have a reference for authorities or for someone that want to work about phytostabilization or something. We want also to produce a WebGIS platform where users can download the data or query the data or visualize the results. And moreover, we are still working now on finding an algorithm able to describe the correlation between the different data sets. So to combine spatial and non-spatial parameters in order to produce an indicator able to give us information about the phytostabilization trend. Thank you for your attention.
Thank you, Enrica. Are there the questions? No? Okay, thank you, Enrica. And we can to pass the presentation to Luca Pirodi. Luca Pirodi presents the work medium to high resolution integrated geophysical surveys to reconstruct an archaeological settlement, new perspective from the ancient town of Nora, southwestern Sardinia, Italy, preliminary results. Luca, can you start?
Yes. Thank you. Do you see the screen?
Yes.
So, good morning. In this note, we present an integrated geophysical survey in the area of the ancient Roman town of Nora that was carried out mostly when I was enrolled at the University of Cagliari. The site has been the focus of a few geophysical campaigns along 5 years from 2008 to 2013, and we will focus on the last one. The archaeological site of Nora is localized in the southern coast of the Gulf of Cagliari in Italy, here in the southern Sardinia. And the ancient town was built on a little peninsula in the isthmus of Capopua, and in the past was characterized by a strategic position as a fundamental maritime crossroad in the ancient Mediterranean Sea. The site currently dedicated to the archaeological park, which is open to visitors, is in the southern part of the peninsula, is indicated here with the yellow area. We can see the topography of the site, an enlargement, with the identification of an upper hill here on the east side, on our right, where there is a coastal tower with the lighthouse, and two small hills bordering the archaeological park. In particular, this one is the northern limit of the consolidated archaeological park, and is partially excavated, but mostly at the time of our campaign was not excavated, and is known as Colle di Tanit. We see an aerial view of the archaeological park with the archaeological remains, while the first settlements dated back to the Nuragic period. It is well documented also the presence of Phoenician communities and most of the building structures found in the site are reconductible to the Roman age. Looking from the lighthouse to the park, here we see a pictures. This is the archaeological park, and here there is the limit of the Colle di Tanit. In this part, we see an enlargement. In this part indicated with B, there is the area in which we collected our geophysical data and jointly started the archaeological investigation. A plan view of the various campaigns, and of course we focus on the last one. That was done in 2013 with the application of different geophysical techniques on the hill bordering the archaeological park. The methodological approach for the acquisition of the geophysical dataset was in fact based on the complementary use of fixed arrays and mobile measurement systems for a fully non-invasive inspections of area based on different irregularities under the macro and micro topography point of view. Irregularities in the ground surface. It was carried out a multi-channel GPR survey and electromagnetics induction survey and electric resistivity tomography survey. We see a few images from the field works. First, I present the electric resistivity tomography data, in which two orthogonal datasets were acquired in the southern western part of the hill, with different specifics depending on the surface logistics that are these two. We will see one by one them. The first data set, that is also the more detailed, was gathered at the top of the hill in the southeastern, here we see the plan view, in the southeastern corner of the hill. I forget to mention that this large area in the past was in use to the Italian Army, the Navy, and it was dismissed just a few years before our study. And in this part of the region of study, we were able to collect data with half meter inter-electrode distance and half meter inter-lines distance, and thanks to this quite high resolution, we were able to detect various alignments in our inverted data that we reconducted to potential archaeological features. The second ERT dataset was collected in the slope from the top of the hill to the sea. Due to bigger difficulties in logistics, we were able to collect data with 1 meter of inter-electrode distance and 2 meters of line-to-line distance. And despite, of course, we were not more able to recognize potential features such as walls, for example, buried walls. We were anyway able to detect some coherent signals, patterns of resistive volumes that we reconduct to structural elements such as Roman insulae or a road. Frequency domain electromagnetic survey was carried out using a CMD1 antenna. Here we see the map at 1.5 meters depth, in which the most interesting elements for a potential archaeological content are these dark blue rectangles, which are potentially due to the presence of voids or tombs in an area that in the past was indicated for a Punic Tophet, so a necropolis, while the high conductive linear patterns imaged with red colors is most probably a modern infrastructure due to the military use of the area. The last technique that we applied was the multi-channel gun penetration radar that was collected by means of, was carried out with an array of 16 antennas of 200 megahertz, meaning 15 radar grams per spot. And this system was towed by a motorized vehicle and was carried out over most accessible surfaces, for which even some regularization preparatory works were needed, such as moving stones from the path of the car and the radar. Here we see the areas covered by the GPR survey, and on the left a small image of the system in work. That was data were positioned thanks to a GNSS differential GNSS system and a radar Doppler system. The radar collection, and for most difficult areas and smaller areas, a customized system was adopted with only 8 antennas from the original system to be pushed by hand by an operator. I show you quickly the radaring program, just a few seconds in during the acquisition. Okay. And finally, we look at the depth slices. The first one confirms the asperity of the ground surface. In fact, there is a lot of noise, despite some signals are possible to be detected. But from 10 centimeters depth to bigger depths, lots of anomalies were found, many of which seems to belong to regular pattern. For example, here we can appreciate some orthogonal and oblique patterns. Here we have another family of principal directions, another strong signal here, and a curious anomaly here that is this semicircular, and we'll see in the next slide how this will behave. Going down, we can note a decrease of the anomalies number, and between them we can note a linear anomaly on the top linked to a drainage tunnel, and the semicircular shape that we already mentioned. One at half meter, this shape became more evident, and at 60 centimeters, it's the map is more clean. We see some features probably linked to walls or to a urban structurization. From 70 centimeters downward, regular anomalies are still present again. And under 1 meter, they gradually disappear. Here we can see the radograms coinciding with some anomalies that are peaked at 60 centimeters depth. And we see some signal features, in particular the B anomalies has a very particular shape with a three-dimensional cluster of high amplitudes. A cumulative amplitude visualization confirms the importance of that anomaly. And the archaeological excavation found at that point an exedra and a monumental square. The excavation carried out by the archaeological team of the University of Cagliari began in 2013 in parallel or just in parallel with the first geophysical campaign, and work concentrated in approximately 15,000 square meters. Found some residential and public spaces, and are still going on. Even now, the team of Cagliari University is digging at the site, and we expect to perform a few measurements to constrain better the results even under the geophysical point of view. Concluding, the experimental application of multiple geophysical techniques to the wide archaeological area of Nora confirmed that the old Roman town was substantially bigger than the current extension of the archaeological park that was in part already known, but structures suspected to have residential, recreation, of infrastructure function were discovered or better characterized with respect to the previous knowledge, and giving a new light to the landscape of historical landscape of the ancient town of Nora. And more diagnostic and joint interpretative actions are needed, but the integrated use of different geophysical methods jointly with the archaeological investigation had led to a new awareness of the importance of the ancient town of Nora by its building ruins, partially still buried. And furthermore, its relationship with the ancient territory and the landscape is now more evident, thanks also to the previous campaigns that were able to image the amphitheater of the city of Nora and some structures underwater in the lagoon close to Nora. Thank you. I finished.
Thank you, Luca. Are there the questions? Okay, so we start the third presentation. Present Vincenzo Gentile, and the title is Towards the Construction of a Hypothetical Map of Santa Maria dell'Antigua del Darién, Colombia, the first Spanish city in the American mainland, an overview of 10 years of a communitarian and multidisciplinary archaeological project. Vincenzo,
thank you.
start.
Show you look the screen?
No.
No?
Okay. Now?
No, yes, but not the presentation.
One moment.
Okay.
Okay.
Perfect.
Good morning. I'm Vincenzo Gentile of University of Molise, and today my presentation is based on the multidisciplinary research in the archaeological sites of Santa Maria dell'Antigua del Darién. Okay. Santa Maria dell'Antigua del Darién.
Okay, yes. Okay, no. Okay.
Perfect. Santa Maria dell'Antigua del Darién is located in the north part of Colombia, on border with Panama. The archaeological sites of the city of Santa Maria is located in the municipality of the Unguya. Is in this way. In the 1510, Santa Maria dell'Antigua del Darién was the first Spanish city to be founded on the American mainland. The Santa Maria del Darién project, promoted by the Ministry of Culture of Colombia and the Colombian Institute of Anthropology, was launched in 2013. The research activity involved different institutions with expertise in different disciplines. During 10 years of activity, it is effectively identified and located the colonial city of Santa Maria. And the first phase of the project is the study of archaeological historical maps. The first phase is concentrated on the search of toponym of Darién. In the cartography of the New American lands, there are a genesis of the name which appear in different form in the 9 maps drawn up from 5031 to 7064. The name of Darien is here. Here is a different location on the map. The analysis of historical maps show that the city was initially indicated in cartography with the Darien River. In any case, historical maps do not provide two exact and univocal location of the city. And the location of the Darien in this slide, we can see the survey if we use to study the area. Allora, the image of reconstructive in this image we are studying and interpreted an area of 45 kilometers. Particular attention we can see on definited the indigenous material with the indigenous material and the Spanish finding in the place. The reconstructive, the study of the satellite image, the study of the satellite image supported by field workover permitted to reconstruct the principal paleography, particularly regarding of the original course of Darien River, today the Tanella River, and distinguished to the regular grid agricultural of this in orange line. In 2016, the photogrammetric survey was carried via drone with obtain a high resolution orthophoto and a digital elevation model. Thanks to the topographic survey, it was also possible to georeference the planes of previous excavation. In this slide, we can see the high definition model and the excavation of the plains of Arcilla Valles and Verlinder. Specified sites where excavation were carried out. From this, it was possible to see and understand that the two archaeological expeditions concentrated on the south part of the city. In this slide, we can see the density of the finding of the archaeological prospection. Green circle indicate a Spanish find, orange circle indicate a pre-Hispanic find, and the negative test are marked with a black triangle. On this slide, it's possible to see two large areas with high density of material. One near the Catholic Church and another one near on the area of Santuario. Thanks to this information, geophysical survey were planned using georadar and geoelectric method. The first area was investigated is the area of Santuario. The GPR results highlights on a series of anomalies within half a meter of depth. Subsequently, the archaeological excavation linked this anomaly with the canalization of the indigenous period. One upper on level Hispanic material and the pose of this or the post also from a probable house. From 2014 to 2021, stratigraphic investigation have carried out in 9 large area. From the colonial phase, the element of stratigraphic excavation, we have the western street of the city, the indigenous house, the canalization and a lot of number of material culture objects. Thanks to the excavation, we have put on the map all the evidence, and in this map we can see the preliminary archaeological map, the area of Santuario, and the spatial archaeological environment. There is in 2016 we have carried out the geophysical prospection using GPR prospection. We can see two different alignment of anomalies. The anomalies with the red line is the colonial phase of the city, and the color of green, of black, is the pre-Hispanic phase. This is important. Look at the different organization of the orientation of the anomalies. And finally, the project is very important to promote a build of archaeological park for exhibition of archaeological finds and the construction of heritage house. Thank you.
Thank you, Vincenzo. Other questions? No? Okay. So we can start to the fourth presentation. The speaker is Andrea Angelini, and the title is Joint Use of Geomatic and Geophysical Methods for the Survey and Documentation of the Vespasian's Thermal Bath, Città Ducale, Rieti, Italia. Andrea, can you start?
Yes, I hope that you are able to hear me now and that the screen is well shared.
Yes.
Can you confirm?
Yeah.
Okay, so hi everyone. I'm Andrea Angelini, a researcher of the Institute of Heritage Science of the CNR in Italy. And today I'm presenting some results about a project funded in 2017 by the Italian Ministry of University and Research in the frame of the action projects of relevant national interest of Italy. So a little introduction. The project had three main objectives. The study model based on the multi-scale and interdisciplinary approach for archaeological investigation, the experimentation of different diagnostic techniques whose results are also useful for calibrating the survey methodologies, and the last one, the link and integrate the results within a GIS platform for different geomorphological analysis and thematic representation. So the subject of the investigation was the archaeological area of the so-called Baths of Vespasian in Città Ducale, Rieti, where following recent excavation campaigns carried out by the superintendency, a clear section of the ancient Via Salaria, about 30 meters long, was found. The choice of the sites was conditioned by the pandemics, because this project was not only 3 years, but ended last year. So we have the opportunity to study this place that is very near to our office in Rome. So this is the reason why we focused our attention on these sites. And on the slide is possible to see the thermal belts that is composed by different places. In particular, we have the thermal buildings, the main one basin that was used for the thermal activity in the ancient times. The medieval area here on the left, that is the Church of Santa Maria dei Cesoni. I don't know why the figure is missed, but this is the position. And this is the most important part that is related to Via Salaria, the ancient stretch of the Via Salaria that was discovered in 2012. So from an historical point of view, from what concerned the cartography, in the Tabula Poetingeriana, that is a 12th and 13th century copy of an ancient Roman map showing the roots of the Roman Empire, the site of Cotilia is localized with the symbol used for thermal structures in the variant with a quadriporticus and 2-tower facade, indicating the presence of the complex, which probably also constituted the resting place for travelers. So here we have exactly the place that we decided to investigate with this project. So first of all, we decided to do survey of the visible. And so the objective of the project, one of the main project objectives, is to represent at the appropriate scale the set of visible structures and environmental context in consideration of the strong vegetation that characterize the area, and for a timely and accurate description of the territory on which archaeological structures stand. Operating in a heterogeneous context and with different levels of detail has led to the integration of various relevant instruments. It was therefore decided to operate on 3 different levels, one relating to aerial vision using historical images and new acquired images by drone, another relating, or UAV, another relating to the architectural scale with the use of a laser scanner, terrestrial laser scanner, and photogrammetric instrumentation, the last relating to the visualization of what is below the ground through geophysical diagnostics. Regarding on-site surveys, part of the work was carried out using structure for motion-based digital aerial photogrammetry systems. The surveying was aimed to reach a large-scale knowledge of the site and was carried out using remotely piloted aircraft. Data processing of images was performed with Metashape Agisoft software using the structure from motion technique. The area of the pool and the surrounding structure was surveyed with a laser scanner. In this case, it was necessary to use a long-range instrument to record both the elevated structure and the context relating to the terrain to precisely describe the geomorphological trend with high resolutions. About 40 high-resolution scans were performed on the entire area. Particular attention was given to the enormous natatio, the basins, which occupies almost the entire upper terrace. The part of structures relating to the medieval church was also surveyed with a laser scanner to have an accurate geometric description of the western part of the site. The ancient route of the Via Salaria was the subject of more in-depth analysis concerning the general objectives of the project, and it was surveyed both with the laser scanners and with the photogrammetric system hooked to a carbon pole. In this case, the use of reflex camera, that was a full-frame camera with a 28mm optic lens mounted on a carbon telescopic pole of 6 meters, allowed to several high-resolution shots to be taken, which were subsequently oriented using an integrated laser scanner data. This is part of the processing in Metashape with some specific and details about some strange anomalies made by limestone over the street. For what concerned data, they were processed according to widely standardized protocol in different application sectors for the management and restitution of point clouds. The latter were also georeferenced within a topographic network built to organize the data in a single reference system aimed at an overall vision of the area within GIS platform or data viewers. In particular, our project was made in collaboration also with the Faculty of Engineer of Sapienza. So they were very interested in, for what concern exactly the graphic documentation and the constitution of the material of the street. So we decided also to create map, plans, elevations, section, all the most important information about this part of the ancient Salaria that was found some years ago. So we decided also to do the geometric survey and some cross sections and different to analyze, for example, inclinations to have different information about this part of the street. After that, we passed to the survey of invisible. This part was developed by the University of Molise, and preventive non-invasive geophysical surveys were carried out on the first terrace with the aim of outlining in detail the route of the Via Salaria, partially identified southeast of the area, as just said before. The investigation were partly overlapped with the areas investigated in 2020 by the British School at Rome in collaboration with the St. Mary's University of Halifax and McMaster University. In 2021, GPR surveys were repeated as part of this project with the aim of increasing the depth of the investigation and qualitatively correlating the data with the distribution of the elevation of the entire surface. During data acquisition, GeoRadar was used, equipped with a 200 MHz antenna. The survey covered an area of approximately 4,400 square meters through a regular grid of profile spaced 1 meter apart, considering the overall size of the investigation area and investigative purposes. In this way, the most useful detail resolution for data processing and interpretation was obtained. Raw data were processed using standard methodological approaches, data and trace editing, subtraction of the DC drift in the data, time zero correction, bandpass filter, background removal, and automatic gain. The entire dataset was used to extract horizontal sections relating to different time windows equal to 4 nanoseconds with an overlap of 1-2 nanoseconds. By combining an average speed of 100 meters millimeter with some diffraction hyperbolas identified near specific objects, the estimate of the depth of the expected buried elements was found to be confined to the volume of soil included in the 0-3 meter interval. That was something that we expected due to the fact that we have the section after the excavation of the street in this part. We know exactly which was more or less the differences in it between the plateau and the area in which the street was found. So in this way, it was very useful to calibrate the instrumentation through these distances. Figure shows some more significant horizontal sections. Image analysis allows the recognition of complex regular system of maximum amplitudes of electromagnetic signals. Starting from the most superficial horizontal section, some anomalies with north-northeast, south-southwest orientation are noteworthy, which are most likely attributable to recent agricultural channels. 2 of them are partially visible in the field. From a depth close to 1 meter onwards, alignments begin to be noticed, which with variable intensity persist up to a depth of 2 meters. Focusing attention on the Via Salaria, the analysis of radargrams provided the approximate section along each transect. 5 meters from the edge of the archaeological excavation, so starting from this part exactly, the profile of the road is very clear. The localization depth of the road pavement at this point is approximately 2 meters. The anomaly is also visible at 11 meters and 15 meters from the edge of the trench. Here, in the initial part of the profile, the anomaly corresponding to what could be a structure to the north of the road is also evident. at 31 meters from the edge, while the hyperbola representing the wall parallel to the road appears clear. There is no clearer evidence of the Via Salaria. This interruption, that is this part, is approximately 30 meters, and it could indicate the absence of paving stones and curbs in that strips of land. Continuing towards the west, the road is detected again, although at a lower altitude. Since the area is characterized by a strong presence of vegetation at the limits of the archaeological structures, with particular concentration in the northeastern area, and in consideration of the morphological complexity of the sites, it was also decided to use the LiDAR information of the integrated online services of the geoportal of the region to those obtained directly with a flight performed in April 2022. From the WMS services of the geoportal, it was possible to visualize on Google Mapping both the DSM and DTM for the Reatino area from LiDAR, excluding the predominant vegetation. As visible in the figure, although the scale of representation is high and the resolution of data is 1 meter, it is possible to observe some very interesting anomalies of archaeological nature. The most obvious one is the continuation of the substructure wall of the second terrace in an easterly direction for at least another 50-60 meters, where it is also possible to see the corner that turns to the north. This discovery makes it possible to re-establish the correct extent of the terrace by decentralizing the reading of the infrastructure just to the east. A little further north, is possible to identify other small anomalies of an archaeological nature, probably related to the structure of the beds, just like here. Only a field analysis will clarify the real nature of these anomalies, referring them to the ancient structures. LiDAR acquisition was also performed in 2022 with a specific instrumentation and covered an area of about 26 hectares. The flight was conducted at an altitude of 70 meters above ground level at a constant speed of 3 meters seconds in dual acquisition grid mode, with UGCS Pro software using the digital elevation model provided by Tinitaly for the Italian peninsula. After that, we decided to do integration between LiDAR and TLS data. The data thus generated were subsequently imported into QGIS for analysis and identification of traces of archaeological interest. This is one of the main results. The DTM and its derivatives obtained from LiDAR and TLS data show multiple evidence of archaeological interest hidden beneath vegetation or soil. In the latter case, the traces manifest themselves in the form of topographic release. Analysis of the data revealed a number of evidences which cannot be found with the most common aerial photography and photogrammetric techniques. The figure confirms with greater detail the anomalies recorded by the online services and show with high resolution additional anomalies, some of which are sure to be of anthropic origin, while others yet to be assessed directly in the field. The numerical data resulting from the LiDAR and laser scanner were used for a methodological comparison with the results derived from the geophysical acquisitions. The overall and unstructured LiDAR point cloud was compared through the DSM inspection filter of the laser scanner data, acquired some time before at a time when no vegetation was present on the ground, and performed with a specific software JRC 3D reconstructor. This filter, so the inspection filter, was used on some specific areas, in particular the lower terrace that is in the image and the large basins, in order to better define the anomalies present in the area. The filter is based on the analysis of the differences in the relative altitudes of the part examined, and is therefore able to clearly highlight what is on the ground from what is vegetation. Usually, the inspection filter is based on the definition of a specific plan, auxiliary plan, positioned at a predefined distance. But in this case, however, it was decided to use the inspection filter by subtracting the LiDAR numerical model to the one acquired from the ground with the laser scanner in the same area. In this way, The displayed map corresponds to the difference in height of the vegetation present in the area in a specific moment. The growth of vegetation on the lower terrace is particularly interesting when compared to the anomalies found in geophysical results. The comparison between the two images of the figure suggests an affinity between what is visible on the surface and what is below the walking surface up to an height of more or less 1 meter. The direction and some forms of the vegetation give us indication on how the road axis must have developed in this part of the terrace. This experimentation certainly allows us to analyze the methodologies used in greater detail and see, for example, based on vegetative growth, how much anthropic material we should expect below and possibly at what altitude. Same experiment was also conducted inside the large basin. In this case, the area was not investigated with geophysical survey, but the results of the anomaly is clearly visible in the figure with different color. We try to highlight better this strange shape and geometry inside the basin. In the figure, it is possible to find an off-center rectangular shape of more than 25 meters on a side in the south direction, located at a lower level than the surface of the basin, which suggests older phases or maybe buried structures. So, to conclude, the integrated reading of the territory on a large scale is now necessary for any archaeological study through the use of aerial, drone, or LiDAR images, but above all, numerical data present in different databases or acquired at the moment. The numerical data available, combined with zenithal and oblique shots, allow an interpretation of anomalies that has never been achieved in this area, and to identify archaeological structures or real inhabited centers that are in fact not visible. The contribution of new technologies has actually paved the way for the use of instruments capable of mapping a large area and the surrounding territory directly from below, which was unthinkable until a few years ago. The same applies to photogrammetric processes, which moreover now also benefit from drone acquisition at a very low altitude, as well as geophysical systems that have been mapping the territory below ground level for many years. The acquisition of millions of pieces of information during survey campaigns allow us to position ourselves at an advantageous point for the final interpretation of the data, and from which we can associate different levels of detail and heterogeneous data as long as they are in the same reference system. This is what was pioneered at the beds of Vespasian and is often applied in the survey of ancient centers. The reading of a territory can now make use not only of images from above, but also from diversified multi-scale territorial analysis systems that concur towards the same result. The research work highlighted the importance of cross-skills and diverse approaches in calibrating study methodologies and obtaining more information about the territory under investigation. And here I conclude my presentation with the acknowledgements, with the special thanks, and what was exactly the project funded by Italy.
Thank you, Andrea. Are there questions? No? Okay, thank you, Andrea.
Can I interrupt my share screen?
No?
No.
So it's possible. Are there Valentina or Anna for the last presentation? No? Sara, do you know if Valentina or Anna have to present?
No, I don't know anything. I don't know if his fellow gypsy is some of them, but I don't know, I really don't know.
Okay. So we can close this session, Sara. Okay.
Just maybe wait until 12:20 because should we start at 12:20 the last presentation.
Okay.
After that, anyone is online, we can conclude the section.
Okay. So we wanted to thank you all speakers and Sarah for the assistance. Have a good day today in Italy because the day is starting. So thank you and bye next year. Okay. Bye bye.
It's a pleasure. Thank you. Hi, everyone.
Bye.
Thank you for all.